Hi, hello, this is Gary teaching 10th Mathematics, the chapter sets. Here are some important concepts and questions and solutions from exercise 2.2. Now, look at the different types of sets now. What are the different types of sets? Let us know now. First of all, what is a set? I shall revise. A set is a well-defined collection of objects. Set is a well-defined collection of objects. Now look at the different types of sets. The first one is an empty set. The first type of the set is an empty set. The set with no elements is called an empty set, which is also called as null set, or it is also called as void set. And it is denoted by set brackets with no elements or the symbol phi. You should read this as phi. Okay? An empty set means a set without elements, or a set with no elements is called an empty set. This is also called as null set, and it is also called as a void set. This empty set is represented by these curly brackets without any element or the letter phi. Example. Now what is an empty set? I may give an example. See here. A is equal to set x such that x is a negative natural number. Is there any negative natural number? No. Natural numbers may start from 1, 2, 3, 4 and so on are natural numbers. In the set of natural numbers you cannot find any negative natural number. Therefore there is no element belong to this set. Therefore it is an empty set. Next is singleton set. Singleton set means a set with only one element is called singleton set. If in any set there is only one element, such set is called singleton set. For example, B is equal to set A. Here how many elements are there? Only one element A. Therefore this set B is called singleton set. Another example. C is equal to set X such that X is an even prime number. The prime numbers may start from 2, 3, 5, 7 and so on. Out of all the prime numbers, only 2 is the even prime number. Therefore there is only one element in this set. Therefore it is a singleton set. And the third one is universal set. A set with all likely elements is called an universal set. A set with all likely elements is called an universal set. And this universal set is represented by U or mu. These two are used to represent an universal set. For example, if you consider the students in your school, the students in your school is a set. Now, at the time of Independence Day or some other sports day or some other sports events, our PD sir used to pick up some students as cricket team and some students as volleyball team and some other students as kabaddi team, like this. Now, whole set of students of the school is called as universal set. You can consider it as universal set. Now, the set of kabaddi players is a part of universal set. The set of cricket players is a part of universal set. The set of tennis players is a part of universal set. Therefore, if we consider the total set of students in a school is universal set, from this universal set you can pick up the remaining sets. Therefore the set of students in the school is called universal set. Means a set with all likely elements is a universal set. From this universal set only you can list out the remaining sets. This universal set is represented by U, capital U or mu. In Venn diagram, this universal set may be represented with either square or rectangle. The next is finite set. if the number of elements is finite in any set, if the number of elements is finite or countable, such set is called finite set. For example, D is equal to set X such that X is an vowel. Now what are the vowels? A, E, I, O, U. There are 5 vowels in English alphabet. You can count the number of vowels. Therefore it is a finite set. Here X is such that X is a person on globe. You can count the population of the globe. Though it is a big number, a very big number, you can count the number of persons on the globe. Therefore again it is a finite set. If it is countable, it is a finite set. And at the same time, I may say that an empty set is also a finite set, because you can count how many elements are there in an empty set. You can say how many elements are there in an empty set. In an empty set, the number of elements is 0. It is countable. Therefore, every empty set is a finite set. And the next is infinite set. The name itself indicates if the number of elements of a set is infinite, then it is called an infinite set. Example, n is equal to, n means natural numbers, is equal to set 1, 2, 3, 4 and so on. There is no end. Therefore, it is called an infinite set. How many natural numbers are there? Infinite natural numbers are there. Therefore, there are infinite elements belong to this set. That's why it is called an infinite set. Take this example. S is equal to set X such that X is a star in the sky. You cannot count the number of stars in the sky. Therefore, it is infinite. Whereas you can count the number of persons on the globe. Therefore, it is finite. The next is subset. If every element of a set is also an element of another set, then the first set is subset to the second set. This I shall repeat. If every element of a particular set is also an element of another set, then the first set is said to be subset to the second set. If there are two sets, if all the elements of the first set are also elements of the second set, then you can say that the first set is subset to second set. I shall give an example. Here A is equal to set 1, 2, 3 and B is equal to set 1, 2, 3 and 4. Now you can observe every element of A is also an element of B. Every element or all elements of A are also elements of B. In such a case, you can say that set A is subset to B. A is subset to B. A is subset to B. Here, A is subset to B. You can represent like this. In set A, 1, 2, 3 are the elements, and in set B, 1, 2, 3 and 4 are the elements. Every element of A is also present in B. In such a case, you can say that the first set is subset to second set. Go for the universal set also. I previously gave an example. Universal set, we took the set of students of a school as universal set. And for this universal set, there are subsets like set of volleyball players, the set of cricket players, the set of kabaddi players, like this. The set of cricket players and the set of volleyball players and the set of kabaddi players are subsets to universal set. Therefore, every set is subset to universal set, and phi is also subset to every set. There are two important points you should note down. Every set is subset to its universal set. And the second point is empty set is subset to every set. Now, let us know the different operations on sets. Let us know the different operations on sets. The first one is union of sets. Union of two or more sets is the set of all elements that are present in any one of these sets. For example, here if you consider the set A as set 1, 2 and B is equal to set 2, 3, 4, then A union B is equal to set 1, 2, 3, 4. You see, union of sets is nothing but the union of both the elements. I mean, the elements that belong to the first set and as well as the elements that belong to the second set. You should list out all the elements that are present in first set and also present in second set. That is called union. The name itself indicates union. Union means the sum of. Therefore, you have to sum up the elements of A and the elements of B, and you have to write them in an order that will be A union B. You see here, A is equal to set 1, 2 and B is equal to set 2, 3, 4. Then A union B is equal to 1, 2, 3 and 4. These are the different elements that are present in first set A and also in second set B. Therefore, union of sets is the union of two or more sets in the set of all elements that are present in any one of the set. This is union. Now, the set builder form. The set builder form of A union B is equal to. Now, if an element belongs to A union B, then it means that element may belong to the first set or it may belong to the second set. You see here, A is equal to set 1, 2 and B is equal to 2, 3, 4. If 1 is present in first set, you wrote in A union B. And 2 is present in both the sets, again you wrote in A union B. And 3 and 4 are not in A but they are in B, even though we wrote in A union B. Therefore, A union B is nothing but the sum of all the elements of the first set and as well as the second set. Therefore, the set builder form of A union B is X such that X belong to A or X belong to B. And now the second operation is intersection of sets. Intersection of two or more sets is the set of elements that are common in all the sets. Intersection of two or more sets is the set of elements that are common in all the sets. For example, if A is equal to set 1, 2, 3 and B is equal to set 2, 3, 4, then A intersection B is equal to. Now we have to list out the elements that are present in both the sets, which are common elements in both the sets. Now what are common in both the sets? The element 2 is in A and also in B. The element 3 is in A and also in B. Therefore, only the elements 2 and 3 are present in both the sets, and A intersection B is equal to set 2, 3. Students, is it clear now? Now, set builder form. The set builder form of A intersection B is X is an element in A intersection B only when X is present in A and also in B. That is X such that X belong to A and X belong to B, means X is common in both the sets A and B. Now, dear students, let us try to distinguish between union of sets and intersection of sets. Union of sets means you have to write all the elements that are present in the first set are also in the second set. Therefore, an element in A union B means it present either in the first set or in the second set. But whereas intersection means it should be common element. That element should present in both the sets. Here you see A intersection B is equal to set 2, 3. Means 2 is an element in the first set and as well as in the second set. And 3 is an element in the first set and as well as in the second set. Then only you can write it in A intersection B. Then the set builder form of A intersection B is X is such that X belong to A and also X belong to B. Means X is a common element in A intersection B. I shall repeat. If you list out all the common elements, then it is intersection of sets. If you write all the elements of the first set and as well as the second set, then it is union of sets. That is the difference between union of the sets and intersection of sets. And the next operation is the difference of sets. The difference of two sets is the set of all elements that are present only in the first set and that are not present in the second set. You see here is an example. If A is equal to set 1, 2, 3 and B is equal to set 2, 3, 4, then A minus B is equal to. A minus B means you have to write the elements that are present in the first set only, which are not in second set. Now, if you observe 1, 2 and 3, these 2 and 3 are also in B. But only 1 is the element that present to first set. Therefore, if you list out all the elements that are present to the first set only, then this is called the difference of sets. Okay. Now the set builder form. of A minus B is X is such that X belong to A and X not belong to B. The set builder form of A minus B is equal to X is such that X belong to the first set A and X does not belong to the second set B. If an element is present in the first set and it does not belong to the second set, then that element should be in A minus B. This is the set builder form of A minus B. Now we learn three different operations on sets. First is union of sets, second is intersection of sets, and the third is the difference of sets. Union means you have to write all the elements that are present in the first set and as well as in the second set. And intersection means you have to list out the common element that belong to both the sets, that is intersection. And the difference of sets means you have to write the element that belong to the first set only and the element should not belong to second set. Such type of elements which are present in a set is called A minus B. And these are the different operations on sets. Now the chapter sets and exercise 2.2, let us solve some problems and let us know their solutions from this exercise 2.2. Here is question number 1. If A is equal to set 1, 2, 3 and 4, B is equal to set 1, 2, 3, 5 and 6, then find A intersection B and B intersection A and are they equal? Look at the solution here. We have given two sets A and B. A is the first set. A is equal to set 1, 2, 3, 4 and B is the second set. B is equal to set 1, 2, 3, 5 and 6. Now we have to find A intersection B. A intersection B means first write the set A intersection, write the set B. This is equal to, since it is intersection, this is the symbol for intersection. Since it is intersection, you have to write only the common elements from both the sets. Here you can find 1, here also 1 is there, therefore write 1. 2, here also 2 is there, therefore write 2. And 3 is common in both, you write 3 also. But 4 is present in the first set and 4 is not in second set, therefore you should not write 4. And 5 and 6 also are not in first set. Even though they are in second set, they are not in first set, therefore you cannot write 5 and 6. Then A intersection B means common elements from both the sets, which is equal to set 1, 2 and 3. Now let us find B intersection A. B intersection A means first write set B. Set B means the set 1, 2, 3, 5, 6. Intersection set A means set 1, 2, 3, 4. This is equal to, again you have to list out the common elements. Since you are finding the common elements, again 1, 2 and 3 are the common elements. Therefore A intersection B is set 1, 2, 3 and B intersection A is also set 1, 2, 3. Then are they equal, he is asking. Is it clear now? From 1 and 2 you can find from 1 and 2 that A intersection B is equal to B intersection A, both are equal. Now question number 2. If A is equal to set 0, 2, 4 and find A intersection 5 and A intersection A and comment on the result. I shall repeat. If A is equal to set 1, 2, 4, then find A intersection 5. 5 means an empty set. And A intersection A. And comment on the result. Here is the solution. First we have given that the set A is set 0, 2 and 4. Now what to find? We have to find A intersection 5 first. A intersection 5 is equal to, A means set 0 to 4. Intersection 5 means an empty set. Now intersection means common elements. Since there are no elements in the second set, there is no question of common elements. Since there are no elements in second set, the intersection is an empty set only, which is equal to 5. And the second bit is A intersection A. A means set 0 to 4. Intersection again the same set A means 0 to 4. Then what are common elements? The same set 0 to 4 is the common set. Therefore the intersection of A intersection A is equal to 0, 2 and 4. From 1 and 2 you can understand that A intersection 5 is equal to 5 and A intersection A is equal to, you got the same set again. A intersection A is equal to A. Now question number 3. A is equal to set 2, 4, 6, 8, 10 and B is equal to set 3, 6, 9, 12 and 15 and find A minus B and B minus A and comment. I shall repeat. A is equal to set 2, 4, 6, 8, 10 and B is equal to set 3, 6, 9, 12 and 15. Then find A minus B and B minus A and comment. Here is the solution. We have given both the sets. Write the first set. A is equal to set 2, 4, 6, 8, 10. And write the second set. B is equal to 2, 6, 9, 12 and 15. We wrote both the sets. Now let us find A minus B. A minus B is equal to, write the first set A. Set 2, 4, 6, 8, 10 minus B means set 3, 6, 9, 12 and 15. While subtraction, you have to write only the elements that belong to first set only. Now you see here 2. 2 is in first set and not in second set. Then write 2 here. Next 4. You could not find 4 in the second set. Therefore write 4. 6. You can find in second set also. Therefore don't write it. 8. Which is not in second set. Therefore write 8 also. And 10. Which is not in second set. Therefore write 10 also. Then A minus B means you have to write the elements that are present in first set only, which are not in second set. Then the set for A minus B, the solution for the A minus B is set 2, 4, 8 and 10. Now the second bit, let us find B minus A. B minus A means first write the second set B, that is set 3, 6, 9, 12, 15 minus set A, set 2, 4, 6, 8, 10. Now here 3, but you could not find 3 in the second set, therefore write 3. 6, 6 is there, therefore leave it. 9, 9 is not there in second set, therefore write 9. 12 is not in second set, therefore write 12 also. And if you find 15, you could not find 15 in the second set, therefore write 15 also. Then B minus A is equal to set of 3, 9, 12 and 15. If it is not clear to write down, then the better way is simply cancel the common elements from both the sets. You cancel the common elements. If you cancel the common elements from both the sets, you can cancel 6 and 6. If you cancel 6 and 6, then what are the elements that left in first set? 3, 9, 12 and 15. Write them here as an answer. Similarly, in the first case also, cancel the common elements from both the sets. 6 is common, then cancel it. Then what are left in first set? 2, 4, 8, 10. Therefore, A minus B is set 2, 4, 8, 10 and B minus A is set 3, 9, 12 and 15. Like that also you can find A minus B and B minus A very easily. From 1 and 2, can you say that both are equal? When can you say that two sets are equal? If two sets are equal means their elements should be same. In any two sets, if their elements are equal, then you can say that the sets are equal. From 1 and 2, you can write now that A minus B is not equal to B minus A. Now question number 4. If A and B are two sets such that A is subset to B, then find A union B. If A and B are two sets such that A is subset to B, then find A union B. Here, what is the subset we just come across? We learned what is the subset now. Here we have given that A is subset to B. Since A is subset to B, all the elements of A should also be the elements of B. All the elements of A should be in B. Then only you can say that A is subset to B. So, let set A is equal to 1, 2, 3 and B is equal to set 1, 2, 3, 4. Now you can observe that all the elements of A are also in B. Then you can say that A is subset to B. The set A is subset to B. Now, if A and B are two sets, the question is A is subset to B, then find A union B. Now let us find A union B now. A union B is equal to, A means set 1, 2, 3, union B means set 1, 2, 3, 4. Since it is union, you have to write all the elements of the first set and as well as the second set. Then you can write 1, 2, 3 and 4. Therefore, A union B is equal to set 1, 2, 3, 4. Set 1, 2, 3, 4 is nothing but set B. Therefore, this is equal to B. Then what can you understand? We understood that if A is subset to B, then A union B is equal to B. Therefore, you can write A union B is equal to B when A is subset to B. Now question number 5. If A is equal to set x such that x is a natural number, and B is equal to x such that x is an even natural number, and C is equal to x such that x is an odd natural number, and D is equal to x such that x is a prime number, then find A intersection B, A intersection C, A intersection D, B intersection C, and B intersection D, and C intersection D. I shall repeat. If A is equal to set x such that x is a natural number, and B is equal to x such that x is an even natural number, and C is equal to x such that x is an odd natural number, and D is equal to x such that x is a prime number, then find the values of A intersection B, A intersection C, A intersection D, B intersection C, B intersection D, and C intersection D. Here is the solution. We have given that A is equal to x such that x is a natural number. Now what are the natural numbers? Natural numbers may start from 1. Therefore this is equal to set 1, 2, 3, 4, 5, 6, 7, 8 and so on. There is no end. And the second, B is equal to set x such that x is an even natural number. Even natural numbers may start from 2. Therefore B is equal to set 2, 4, 6, 8, 10 and so on. And C is equal to set x such that x is an odd natural number. Odd natural numbers may start from 1, which is equal to set of 1, 3, 5, 7, 9 and so on. And D is equal to set x such that x is a prime number. The prime numbers may start from 2. Therefore D is equal to 2, 3, 5, 7, 11 and so on. This is set D. Now we got set A, set B and set D in roster form. But we have given ABCD values in set builder form and we converted them into roster form. Now let us find the first bit A intersection B. A intersection B means A set 1, 2, 3, 4, 5, 6, 7, 8 etc. Intersection set B means 2, 4, 6, 8 and so on. Now intersection means you have to write the common elements. You can find 2, 4, 6, 8 in A. Therefore the common elements are 2, 4, 6, 8 and so on. This is A intersection B. And the second bit is A intersection C. Again the same set A, set 1, 2, 3, 4, 5, 6, 7, 8 and so on. Intersection set C. What is set C? Set of 1, 3, 5, 7, 9 and so on. Intersection means again you can find 1, 3, 5, 7 in the first set. Therefore the intersection of A intersection C is set of 1, 3, 5, 7 and so on. Third bit A intersection D. A intersection D is equal to set A, set 1, 2, 3, 4, 5, 6, 7, 8 so on, intersection set D 2, 3, 5, 7 and so on. This is equal to set of 2, 3, 5, 7 and so on. This is A intersection D. And fourth bit B intersection C. Set B 2, 4, 6, 8 so on. Intersection set C means 1, 3, 5, 7, 9 and so on. You see, if you look at both the sets, there is no common element from both the sets. Why? Because these are even numbers and these are odd numbers. There is no even number which is an odd number, and there is no odd number which is even number. Therefore, there is no common elements in both A and C, and its intersection is an empty set phi. And next bit B intersection D. Set B 2, 4, 6, 8 so on. Intersection set D. D means 2, 3, 5, 7 and so on. Now if you observe both the sets, then only 2 is common element. Therefore B intersection D is equal to set 2. Next bit C intersection D. C intersection D is equal to set C, set of 1, 3, 5, 7, 9 so on. Intersection set D means 2, 3, 5, 7 and so on. If you find C intersection D, we have to pick up the common elements. Now what are the common elements from both the sets? 3 is common, you can find 5 common and you can find 7 common. Therefore C intersection D is equal to set 3, 5, 7 and so on. This is C intersection D. Like this you have completed question number 5. Now question number 6. Here is the question. A is equal to set 3, 6, 9, 12, 15, 18, 21. B is equal to set 4, 8, 12, 16, 20. C is equal to set of 2, 4, 6, 8, 10, 12, 14, 16. And D is equal to set of 5, 10, 15, 20. Then find A minus B, A minus C, A minus D, B minus A, D minus A, B minus D, C minus B and D minus B. Here is the solution. We have given set A. Write the set A. Set of 3, 6, 9, 12, 15, 18, 21. And B is equal to set of 4, 8, 12, 16, 20. And C is equal to set of 2, 4, 6, 8, 10, 12, 14, 16. And D is equal to set of 5, 10, 15 and 20. These are the 4 sets we have given. Now let us find A minus B now. A minus B is equal to, write set A first minus set B later. Now in order to find out A minus B, you have to consider the elements that are present in first set only, which are not in the second set. If you find 3, you can find 3 in first set and there is no 3 in second set, therefore write 3. Next 6 is not in second set, therefore write 6. 9 you could not find in next set, write 9. 12 is present in the next set, therefore don't write it. 15 is not there, therefore write 15. 18, there is no 18 in second set, therefore write 18. 21, you could not find 21 in second set, therefore write 21. Then A minus B is equal to set of 3, 6, 9, 15, 18 and 21. And second bit A minus C. Again write A set minus C set. Set of 2, 4, 6, 8, 10, 12, 14, 16. Then since it is minus, you come to the first element 3. 3 is in first set. Then can you find 3 in second set? 3 is not there in second set, therefore write 3. Next 6, you can find 6 in here, therefore don't write 6. 9, there is no 9 in second set, therefore write 9. 12, you can find 12 in second set, therefore leave it. 15, there is no 15 in second set, therefore write 15. And 18, there is no 18 in second set, therefore write 18. And 21, 21 is not there in second set, therefore write 21 also. Then A minus C is equal to set of 3, 9, 15, 18 and 21. Now third bit is A minus D. A minus D. Write set A first, this is set A, minus set D, means set 5, 10, 15, 20. This is set D. Now subtraction. Subtraction means you have to write the elements that are present in first set only. 3, you could not find 3 in second set, therefore write 3. 6 is not there, therefore write 6. 9, no 9 here, therefore write 9. 12, there is no 12 in second set, therefore write 12. 15, you can find 15, therefore leave it. 18 and 21 you could not find here, therefore write 18 and 21. So A minus D is equal to set of 3, 6, 9, 12, 18 and 21. And fourth bit is B minus A. B minus A means first write B set 4, 8, 12, 16, 20 minus A set of 3, 6, 9, 12, 15, 18, 21. Now 4 not there in second set, therefore write 4. 8, you could not find 8 in the second set, therefore write 8. 12 is there, leave it. 16, there is no 16 here, therefore write 16. And 20, there is no 20 in the second set, therefore write 20 also. Then B minus A is equal to set of 4, 8, 16, 20. Next fifth bit is D minus A. Set D is set of 5, 10, 15, 20. Minus A is set of 3, 6, 9, 12, 15, 18, 21. Again you have to go for the subtraction. 5, there is no 5. And 10, there is no 10 there, therefore write 5 and 10. You can find 15 in both, therefore leave it. And 20, you could not find 20 in the second set, therefore write 20 also. Then D minus A is equal to set of 5, 10 and 20. In other way, I told you that you may please cancel the common elements from both the sets. You can cancel 15, 15. If you cancel 15 common elements, then what are the elements left in first set? 5, 10 and 20. You write them here so that you can get D minus A very easy. And the next bit is, sixth bit is B minus D. B minus D means set B is equal to 4, 8, 12, 16, 20 minus set D. D is equal to set 5, 10, 15, 20. Now what are common elements from both the sets? you can find 20 in both the sets. Therefore cancel 20. If you cancel 20, then what are left in first set? 4, 8, 12, 16. Therefore B minus D is equal to set of 4, 8, 12, 16. Like this, you can complete the exercise 2.2. The previous 2.1 exercise and the introduction to sets and the first chapter real numbers and all these video links are given in the description so that you may revise them. Thank you, one and all.